Hello students, today we are doing 12.5 on scatter plots. You have notes that are in Schoology that you can follow along with this so that you can be taking notes as you watch the video. So if you need to pause this, go get the notes, make sure the notes are open as you follow along with the video. All right, so number one asks us to graph the data in the table. So what I've done here is we have taken all of these points from this table right here, and we've graphed them on our coordinate plane. So I put the x values to go up by 1, the y values here to go up by 2 so that they would all fit. Notice these are not a perfectly straight line, okay? It's kind of all scattered around, hence the name scatter plots. Number 2 says draw a straight line that you think best approximates the points. So we want to just draw a line as best we can through the middle of as many points as possible. So it's about right there. We have about 3 points on top of the line and 3 points on bottom of the line. So that kind of approximates all of the data. Then it says write an equation of a line that you drew. And so we can find the slope and y-intercept of this red line, where we can just kind of pick some random points and kind of estimate what we think the slope is. So I'm noticing that it's kind of going maybe up by 2 over 1 in a way. And so we can go ahead and say that we get y equals a slope of 2, and the y-intercept is approximately 3 down here. So it's approximately crossing down here at about 3. So this is just an estimation. Now it says use the equation to predict the weight of 10 bananas. Well, the number of bananas is our x value, so therefore we're going to do y equals 2 times 10 plus 3. So we get 20 plus 3, so approximately the weight of 10 bananas would be about 23 ounces. Good. So scatter plots, some information about scatter plots. A scatter plot is a graph that shows the relationship between two data sets. The two sets of data are graphed as ordered pairs in coordinate planes. We have 3 types of correlations, okay? So the correlation talks about the relationship between the data sets. A positive correlation is when all your points are going up kind of in that positive slope in a way, in that positive direction. A negative correlation is when they're all kind of coming down, like if you were to draw a line through it, you would get a negative slope. No correlation at all is they're all just random. There's no direction of the points going up or going down. So example 1, the scatter plot on the left shows the amount of fat in grams and the number of calories in 12 restaurant sandwiches. A, how many calories are in the sandwich that contains 17 grams of fat? Well, we can use this. We can read our table. 17 is going to be between 15 and 20. There's a point right there that's about at 17. So there's 400 calories in that sandwich. Okay, how many grams of fat are in a sandwich that contains 600 calories? Well, now we're looking at our calories, so 600. And so if we look over here, we have this point right here, right at 600, and that's telling us that we have 30 grams of fat. Okay, so you're getting used to reading your scatter plots. What tends to happen to the number of calories as the number of grams of fat increase? So as the numbers go up here, notice that the numbers are going up here. So you would say that your calories is going up. So if a sandwich has 615 calories, based on a scatter plot in example 1, how many grams of fat would you expect a sandwich with 650 calories? So we can kind of estimate. 650 is right here. So there's no dots that hit 650 exactly, but the dots are kind of around this section. So we would estimate that about 35 grams of fat would be in there around that area. So we could say about 35 grams of fat. Example number 2. Tell whether the data shows a positive, negative, or no correlation at all, or no relationship. So if we're looking at the left one, television size and price, I'm noticing that as these points, they're kind of going up. So therefore, this is going to be a positive correlation. The one on the right, B, age and number of pets, I don't see any pattern at all. The points are just kind of all over the place. So we would say no correlation or no relationship. Example 3, the table shows the weekly sales of a DVD and the number of weeks since its release. Make a scatter plot of the data and draw a line of best fit. Write an equation of the line of fit and interpret the slope of the line of fit. Predict the sales in week 9. So there's a lot going on here. So first, let's graph all of our information. So go ahead and feel free to pause the video, label your number line, 1, 2, 3, 4, keep going. Okay, we're gonna have to make it all the way at the Y values are gonna have to make it all the way up to $19. So I'm gonna go up by 2s here, 2, 4, okay, keep labeling those. And then plot all of these points over here on your graph. Okay, so pause it and then come back to see how to do the rest of it. All right, so here are all the points from this table. I've put a line of best fit in here, so I've just drawn a line that fits most of the points, as many as I can, okay, right through there. It now says write an equation of the line of best fit. So I'm going to look at this blue line, and I'm going to try to write an equation as best I can. So I need to find the slope and the y-intercept. The slope, I'm looking, if I look at like this point right here, and maybe like this point right here, it's kind of off, but I'm looking like I'm coming down to about and going over 1. So I'm going to say the line, the slope is about -2. The y-intercept is going to be up here somewhere. Okay, and the y-intercept is about at 18. This is all about estimating. Okay, so there's that. Then it says interpret the slope of the line of fit. Well, it's a negative slope, and we can see that it's a negative correlation, so that's why we have a negative slope. And predict the sales in week 9. So let's go ahead and plug in a 9 for the X value. So if I do -2 times 9 plus 18, -2 times 9 is -18. Plus 18, and we get 0. So if we're predicting that, we're thinking that it's dropping all the way down here at week 9 to about 0. So not the greatest prediction, but as long as we have our work shown, it is an estimation. So that's it. So go ahead, pause the video, try this one on your own, draw your graph, at least get your points plotted here on your table and see if you can draw the line of best fit. Make it go through as many points as possible and see what you can get. All right, so here's my graph. I went the x-axis by 1s, and then for the y-axis here, since we had to make it all the way to 2400, I went up by 200, so 200, 400, 600, 800, and kept going from there to get that 2400 at the very top. I plotted all the points, and the line of best fit goes through most of the points through the middle. This one at the very top is an outlier. It's very up there, so it's okay that it's off the line a little bit. Okay, when I come back, we'll talk more about writing the equation of the slope. I want you to more so think of interpreting the slope of the line. Is this a positive slope or is it a negative slope? That's what I want you to think about. And this one has a positive slope, so therefore it is a positive correlation. We could also use this data to predict where how many people will attend the festival at year 10. So if you take a look, year 10 is out here. If you look at our line of best fit, we're going to be about at that 2400. Now it might obviously be a little different, especially because at year 8 we were at 2400 already, but looking at the other data kind of got us to predict that it was going to be about up there as well. Okay, that is all for today's notes. So now your homework is on big ideas. Go ahead, file these notes away in Notability and go try big ideas.